In this topic, we shall learn about the sine rule. The sine rule can be used to find the angles and length of a triangle if the conditions are met. Now let's recap. The area of a triangle ABC can be found using the formula half BC sine A. Do you remember what type of angle is angle A? Yes, it must be an included angle. We can also write it as half AC sine B, where B is the included angle and we will use the length AC. Or half AB sine C, whereby C is the included angle and we'll use the length A and B. Now, let's derive the sine rule. In order to do so, we will divide all these three area formulas with half ABC. Now, half divided by half is equals to 1. Likewise for B and C. And hence we can cancel. And similar for the rest of the common terms. After cancelling, these are what's left. And we will have the sine rule, which is sine angle A over A equals to sine angle B over B equals to sine angle C over C. Now, we will apply the formula when given an angle and its opposite side. For example, here we have angle A and we will use the opposite length A. Now, you notice that the side A is opposite angle A, the side B is opposite angle B, and the side C is opposite angle C. So, whenever you're given one pair of angles and its opposite side, you can use sine rule. You can also write the sine rule in this way. A over sine angle A equals to B over sine angle B equals to C over sine angle C. Whether you write it in this way or the other way depends on the unknown that you are finding. If you are finding an angle, it will be best to use this form, as the angle will be at the numerator. If you are finding the unknown side, it will be best to use this form, as the unknown will be at the numerator here. To understand this better, let's look at some examples. We are asked to find angle BAC. Angle BAC. You notice down here we have an angle and a given opposite side. Therefore, we can use sine rule. We will use this form here because we are finding an angle. The angle A here is angle BAC and the length A here will be the opposite length 10 cm. For angle B here, we will use the given angle B, which is 70 degree, and its opposite length, which is 14 cm. To solve this, we will multiply 10 on both sides, and we will have sine angle BAC equals to 0.6712. To solve this, we will inverse sine on both sides, and we will be left with angle BAC equals to the inverse sine of 0.6712. Pressing your calculator and remember to leave it in degree mode, we will have 42.2 degree rounded off to 1 decimal place. And hence, given an angle and an opposite side, we can use the sine rule to find other angles and other length. In this next example, we will find the length BC. Again, you notice that we have a given angle here and a given opposite side, and therefore we will use the sine rule. However, to find BC, we will need the opposite angle, which is angle BAC. To calculate angle BAC, we will use the angle sum of triangle 180 degree minus 70 degree minus 68 degree, which gives us 42 degree. Since we are finding the length, we will use A over sine angle A equals to B over sine angle B. So that the length that we want to find will be at the numerator. On the left hand side, we will have BC over sine 42 degree. And on the right hand side, we will have 20 over sine 68 degree. To solve this, we will multiply sine 42 degrees on both sides. And by pressing your calculator, we will have BC equals to 14.4 centimeters, rounded off to 3 significant figures. Now, let's look at the question whereby there will be an ambiguous case. This occurs when we are given an angle and two sides. For instance, in triangle ABC, we are given the angle ABC equals to 25 degrees, the sides AB equals to 13 cm and AC equals to 6 cm. Therefore, we have an angle and two sides. We are asked to find angle ACB. For an ambiguous case, the diagram will not be given to you. So now, let us sketch triangle ABC. And this is what we will get. However, there will be an ambiguous case here. And let us see how this comes about. We shall now draw a circle with radius 6 cm centered around A. By doing so, we can have another triangle here whereby angle ABC is still 25 degrees, AB is 13 cm, and AC here will be 6 cm. We now have two triangles that satisfy these measurements. Now, to find angle ACB, we will solve it as per normal. Let's start off by looking at the first triangle ABC. You notice that we have a given angle here and the given opposite length. Likewise, to find angle ACB, we are also given its opposite length. And hence, we can use the sine rule. Sine angle ACB over 13 will be equals to sine 25 over 6. To find angle ACB, we need to first multiply 13 on both sides. And we will be left with sine angle ACB equals to 0.9156729. To find angle ACB, we will inverse sine on both sides, and we will have angle ACB equals to the inverse sine of 0.9156729. By pressing your calculator and making sure that it is in degree mode, we will have angle ACB equals to 66.3 degrees rounded off to 1 decimal place. Now, let's look at another triangle AC'B, whereby the angle ABC is 25 degrees, AB equals to 13 cm, and AC equals to 6 cm as well. You notice that triangle ACC' is actually an isosceles triangle. What this means is that the angle here will be the same as the other angle here. In order to find angle AC'B, we simply need to use 180 degrees minus 66.3 degrees because of angles on a straight line. And we'll have angle AC'B equals to 130.7 degrees. What this means is that we will have two answers for angle ACB. In summary, we can use the sine rule, which is sine angle A over A equals to sine angle B over B, or A over sine angle A equals to B over sine angle B, whenever we have a given angle and its opposite side, like this. Be mindful of ambiguous case when given an angle and two sides. To be more precise, the ambiguous case will occur when we are given two sides and an angle, whereby the angle is not an included angle. Also, the length that is opposite the given angle must be shorter than the other length C. Finally, the value of C sin theta must also be smaller than the value of B, which is the length that is opposite theta. And that's all for this topic.